And now, when all is done, there is nothing to say. You have gone and so effortlessly.
Okay, so for today's topic, we are going to learn about extremum of function, which is a continuation from our previous topic, which is functions of 2 and 3 variables. So in our previous topic, we are given functions and we have to find the derivatives. We have to find the fx, fy, fxx, fyy, fxy, and fyx. So in today's topic, we learn about extremum of functions, how to find the critical points. It is about finding the critical points. So, what exactly are extremum of functions? What exactly is critical points? Critical points is basically finding the maximum, minimum, and saddle points. Okay, so how to find the critical points? Okay, finding critical points, we use the formula of fx equals to 0 or fy equals to 0. So from our derivations earlier, we have fx and we have fy. So we equate this fx and fy to 0. So we have function of x equals to 0, and then you get the answer. Okay. And then let's say you have the a, b. This is your critical point. So this a, b, it could either be a maximum point, minimum point, or saddle point. And if you get like 2 critical points, this one could either be maximum point, this one could be minimum point, or both of them could be saddle points. So how do you determine if it's a maximum point, if it's minimum point, or saddle point? So you use a D formula. So the D formula says fxx times fyy minus fxy squared. So fxx you get from the derivatives earlier. Same goes to fyy, same goes to fxy, except that fxy you have to square it. Okay, so when you get the value, if the D is equal to 0, hence there is no conclusion, which means there is no minimum, maximum, or saddle point. Okay, so if the D is less than 0, then it is automatically saddle point. So if you see a negative value, if the D is a negative value, you just write down saddle point. Okay, so that leaves us with minimum point and maximum point. So if the D is greater than 0, it is either these two, minimum point or maximum point. So how do you determine which one is minimum and which one is maximum? So you use the fxx. You substitute the critical values into the fxx function, and if it turns out greater than 0, then it is minimum point. Then if it is less than 0, hence it is a maximum point. So to better understand this extremum of functions, let's move on to example.
Falling out of love is high. Falling for betrayal is worse.
Today we'll be discussing about tutorial 29, which is about the extremum of functions. We've chosen question 13. So the question states, find the relative maximum, minimum, and saddle points of the function given, which is fxy equals to 2x cubed plus y cubed minus 6x minus 12y plus 10. So the first thing we need to do is write back the equation, and then we need to differentiate the x. Everything in the equation that does not contain an x turns into a 0. So it becomes 6x squared, and the 6x becomes the 6, negative. While the fy, we differentiate everything that contains a y, and everything that does not contain a y turns into a 0. So y cubed becomes 3y squared, and the 12y becomes a negative 12. Then we differentiate it for the second time from this equation. So the 6x cubed becomes a 12x, and the 6 becomes a 0. And this one, the fy, we differentiate for the second time, becomes fyy. From this equation, it becomes 6y, while the 12 becomes a 0. Next, we differentiate according to the higher order partial derivatives, which means we take from the back fy, which is this function, and differentiate the x in this function. Since there is no x, they become a constant, which means they become a 0. Same goes for fyx. According to the higher order partial derivatives, we take the one at the back, fx is this one and differentiate the y in the function, but since there is no y, it becomes a 0. Okay, the function of the fx and fy is we need to find the critical points from these two equations. So what we do is we equate the fx and the fy to a 0, which means we take this equation and equate it into a 0. So here fx is 6x squared minus 6 equals to a 0, which is equals to, when we move it, it becomes a 6x squared equals to a 6, x squared is equals to a 1, and we square root it, we come plus minus 1. Next, for the fy equals to 0, we take this equation. It is 3y squared minus 12 equals to a 0. So we move the 12 first. We divide by 3. We square root it and we get a plus minus 2. So this is your critical point. Your critical point is 1 and 2, 1 and negative 2, negative 1 and 2, negative 1 and negative 2. So among these four critical points, there is going to be a minimum point, a maximum point, and also a saddle point. So in order to determine their maximum, minimum, or saddle points, we're going to use a table, which is this table. So first things first, we do this table, and CP stands for critical point, and we insert all the critical points that we obtained just now, which is 1, 2, 1, negative 2, negative 1 and 2, and negative 1 and negative 2. And then the meaning of fxx, meaning you use the function that we got earlier from the second time derivative, which in this case is 12x. You can put it here. Meaning we'll substitute all the x value into this function and we'll obtain the answer. So the answer, every time we substitute the x, 1 we got 12. This function is negative 12. While for the fyy, we use the fyy function that we got earlier, which is 6y. We can write it here. And substitute all the y's that we have for the critical point. This is 2 and negative 2. So 2 substitute here is 12. Negative 2 substitute here is negative 12. Okay. Next, we use the fxy square, which means we take the fxy function that we got earlier, which is this one. It says a 0. So whatever number that we have, we square it. So 0 squared is 0. According to the formula that was given in the book, this formula is to make a conclusion whether it's a minimum or a maximum point, which is also known as a derivative test. I put it. Okay. So since we've obtained all the values that we need, so we just substitute in. This one meaning fxx times fyy. So 12 times 12 in this case is 144. Minus the answer that we got here, which is 0. So your answer is 144. We get a negative 144. This we get negative 144. And lastly, negative 12 times equals to 144. So how do you determine whether it's a minimum or maximum or either a saddle point? So if your D value, which is this one, is less than 0, it makes it a saddle point automatically. So if it's a negative, it's a saddle point. So this 2, which is a negative, is a saddle point. So since you can see that both of the answer for this one is positive, so which one is maximum and which one is minimum? So in order to answer your question, we have to look at the value of fxx, which is inserted with the critical point, and what answer did you obtain. So if your answer for your f(x)(x) obtained when you put in your critical points, if your answer is a positive, then your D is actually a minimum point. If it is less than a 0, then your answer is actually a maximum point. So as you can see from this one, this is more than 0, meaning it's a minimum. And since this one is a negative answer, this one is a maximum point. So this is the answer that you want, but when you write in short form, you don't need to write this. This is only for your view. You only write this critical point and whether it's a minimum point, saddle point, or a maximum point. So that's the end of the video. Bye!
Bye!